Welcome students, let me continue our next class on the topic limits and continuity. See, in this class at the beginning let me discuss the algebra of limits here. Some rules we follow to evaluate the limits here. See, what are those rules? So there is no need of any specific proof for this, just memorize, just a recapitulation here. So basic rules these are. So some rule here, see, this is expressed in this manner: limit x tends to a f of x plus g of x here, fx plus gx, sum is there here. This limit x tends to a can be applicable to both the term fx as well as gx here. You can split and write in this manner, that is limit x tends to a fx plus limit x tends to a x tends to a gx, you can write here. So this is what the sum rule here. So next one is the same here, difference rule here, limit x tends to a fx minus gx here, take the difference here, fx minus gx, the difference of two functions here. So this limit is applicable to both the functions fx as well as gx here. So limit x tends to a fx minus limit x tends to a and then gx you write here. So this is what the difference rule here. So next the product rule, here it follows like this: limit x tends to a fx into gx, if the product of two functions is there, then you can apply this limit to both the terms, both the functions here, not the terms. Limit x tends to a fx into limit x tends to a gx, you can write here. So this is what the product rule here. Constant multiple rule, see, the situation is like this: limit x tends to a, some constant is there here, this is multiplied with the function f of x. It may be lambda or it may be alpha, any constant here. That constant can be taken outside and then limit can be applied to the function here. So what to write here? Constant can be taken outside, I told. So take k outside here, then limit x tends to a, what we can write, fx you can write here. So this is what the constant multiple rule here. Constant is multiplied to fx, that's why that multiple constant can be taken outside. That is what the theme in this case. See, let us see the next rule here, quotient rule here. So limit x tends to a fx divided by gx, if the situation is like this, the ratio of two functions fx divided by gx, then this limit can be applied to both numerator as well as denominator, that is limit x tends to a fx divided by limit x tends to a gx here. So this is what the quotient rule. Next is the power rule, that is limit x tends to a fx is there here, this is raised to the power n, this is raised to the power n, then this is equal to limit x tends to a fx to the power n, So this is what the power rule. So next is constant rule, that is limit x tends to a, if any constant is there here, there is nothing here, no x here, then there is nothing to substitute, simply write k itself here. So this is what the situation, and these are the basic rules that we apply while. Now let us move to the next concept, that is what, see, the methods of evaluating the limits here, working rule, actually how to solve the limit, how to evaluate the limit, that we will discuss here. There are different methods, see, let us discuss one by one here. First one is direct substitution method. See, in the given limit, say if the limit is given, limit x tends to a fx is there here, you substitute the tending limit, this one you need to substitute here, this limit here, tending limit. X tends to a means x is equal to a, you need to substitute here, where? In that function. If you substitute x equal to a in the function fx, if it is not leading to 0 by 0 or infinity upon infinity, something else, indeterminate form, if it is a finite value, then take itself as the value of that limit here. If it is taking the indeterminate form, then we proceed for any other method here, either a standard limit or cancellation. By some mean we can eliminate that step here. See, one or two examples I have given, just observe here, try to understand it. Very easy here. Limit x tends to 1 is there here. And then the function is x square plus 3x minus 6 is there. See its value. According to the algebra of limits, you can apply this limit to every term here. Each term, limit x tends to 1 x square, limit x tends to 1 x square you can write. Then plus limit x tends to 1 3x we can write. And then minus is there in between, you can write minus. Sum and difference rules are discussed now. That I am applying here. Limit x tends to 1 and then 6 you write here. Okay. Now let us substitute the value. X is equal to 1. If you substitute, it becomes 1 square. Be careful, concentrate here. I have substituted the tending limit. The limit value I have substituted. After substituting the limit, no need of writing the symbol LIM. Limit symbol gets cleared here. Okay. And it is not taking 0 by 0 form or infinity upon infinity form or infinity minus infinity form. It is a finite value. So this is what the evaluation or the value of the function at that limit here. Next, x tends to 1 is there. Two rules you are applying at the time. 3 is a constant. You recall constant multiple rule. That constant can be taken outside. 3 you take it outside. And then limit x tends to 1 x remains. There you put x is equal to 1. So 3 into 1 it is. Minus 6 is a constant. Nothing to substitute, x is equal to 1 in the last step here. So simplify this. 1 square is 1 only. 1 plus 3 is 4. 4 minus 6 is minus 2. Okay. Tapidre here and simplification 3 plus 1 4 4 minus 6 is minus 2. Correct it is. Now observe here next one. Here only I would like to continue. This is equal to limit x tends to 0, cos x is there here. Cos x is there here. Please concentrate. X tends to 0. I would like to substitute the value of x which is 0. After substituting, what we will get here? Cos 0 value is 1 here. After substituting the limit value, no need to write the limit symbol. So this is what direct substitution method. We have not at all used any specific formula here. Simply rules of limits we have applied. There is no any proper formula here. No need here. If it is not taking 0 by 0 form, directly you substitute the value and then evaluate the limit. So this is what the first method. Artha aita yenadru illi heliddu? Have you followed? Is it clear for you? If you have any doubt, you tell me. Yenadru artha agilla andre kedri. Now see the next question. Limit x tends to 2, x square minus 4 divided by x minus 2 is there here. Let me take the given limit. X tends to 2, x square minus 4 divided by x minus 2. X minus 2. See, this can be written as limit x tends to 2. How can you factorize x square minus 4? Using the formula a square minus b square. 4 can be written as 2 square. Divided by 2 you write x minus 2 you write as it is. Then how can you write x square minus 2 square? This is equal to limit x tends to 2. Is it not possible to factorize that? Divided by x minus 2 I would like to write. What are the factors of x square minus 2 square? Anybody?
X plus 2 into x minus 2.
X plus 2 x minus 2. Now observe here. Here what happens? X minus 2 cancels. This is what limit x tends to 2. X tends to 2. X plus 2 remains here. See, this is equal to x tends to 2 means x equal to 2 you have to substitute. For calculation purpose, x equal to 2 you have to substitute. X is tending to 2, approaching to 2. But for calculation you are going to write it 2 plus 2 which is equal to what you are getting? 4 you are getting. So this is the value of the limit here. Please concentrate here. Why I have factorized here? Why I have not directly substituted x equal to 2 at the beginning itself? That I would like to make it clear. See, if you substitute directly x equal to 2, in this case what happens? 2 square minus 4 divided by 2 minus 2 which is equal to 4 minus 4 divided by 2 minus 2 which is equal to 0 by 0. This is an indeterminate form. Here you cannot apply direct substitution method. You may question why, sir, you have followed a different method, why you have not directly substituted. Direct substitution is not at all possible here. If you put directly x equal to 2, the function is leading to 0 by 0 form. That's why I have followed a different way. That is what the factorization. I have factorized the terms and that leads to the cancellation of that situation here. See, let us take another example. X square minus 5x plus 6 is there. So first of all, let me find the factors for x square minus 5x plus 6. 6x square is the product of first and last term. You split the middle term here. 3 and 2. So minus 3x minus 2x you can write. The sum becomes minus 5x. And then you know all this fund I have studied at SLC. And then this is x. X you take common, x minus 3 here. Minus 2 you take and then x minus 3 again. This is not plus here because backside minus is there. That plus becomes minus here. So take x minus 3 common. By taking x minus 3, what remains here? X minus 2 remains. I have factorized x square minus 5x plus 6. So before that, one more thing I would like to make clear at the beginning itself. If you put directly x equal to 3, what happens? You see, 3 square minus 5 into 3 plus 6 divided by 3 minus 3. See the numerator here. 3 square is 9. 9 and 6. 9 and 6, 15. 15 minus 15 divided by 3 minus 3. It is leading to what here? 0 upon 0. Indeterminate form. So definitely you cannot substitute directly x equal to 3. And by direct substitution method, you cannot evaluate the value of the limit here. So that it needs to go for another method. So that is what we are following, the factorization method. Now let me take into consideration the given limit. The given limit is limit x tends to 3, x square minus 5x plus 6 divided by x minus 3 here. So this is what the problem here. Limit x tends to 3 you write. X square minus 5x plus 6 I have factorized separately. And the factors are x minus 3 into x minus 2. Let us write that. X minus 3 into x minus 2 here. Okay. Then divided by x minus 3. So x minus 3 and x minus 3 cancels. Remains what? Limit x tends to 3, x tends to 3, x minus 2 remains. Let us substitute the value of x equal to 3 here. So it becomes 3 minus 2. 3 minus 2 is nothing but what? 1 you are getting. So this is what the value of the limit, and the evaluation work is completed. The calculation work is completed. So I have confirmed the factorization method with these two examples. It is in some other examples we will take in detail later on, but just I am introducing the method here. So it's enough, I think. I hope you followed. If you have any doubt, you can ask me. Otherwise, I will move to the next question here. Now, rationalization method here. See, there is an error in the typing. This is a continuation here. This continuation. Here, the problem is like this. Evaluate the limit x tends to 0, root of 1 plus x minus 1 whole divided by x. Here it is. Now, direct substitution, you think. What happens, you see here. Directly, if you take root of 1 plus x is there. 1 plus x value x tends to 0 here. That's why you take 0 here. Minus 1 divided by 1 x tends to 0. So you take 0 here. Root 1 value is 1. 1 minus 1 divided by 0. So what we are getting? An indeterminate form here. So you cannot substitute directly x equal to 0 in this limit, and we need to follow a different method. We cannot factorize also because it is a surd here. Surd is there. You cannot easily factorize that. So rationalization is the best method. So rationalizing factor of the numerator, you think over that, and then multiply and divide by the rationalizing factor of the numerator term. See, root of 1 plus x minus 1 is there divided by x. I would like to take the rationalizing factor. Simply you change the middle sign of that expression in the numerator. 1 plus x is there, minus 1 I would like to write it as plus 1. So in order to tally, I would like to divide it. Root of 1 plus x plus 1 you can write. Now as a result, what happens, you see here, limit x tends to 0, I would like to write 0. See, the numerator is of the form a plus b into a minus b. You know already, a plus b into a minus b, this is nothing but, this product is nothing but a square minus b square. So this relation, this formula or this identity is to be applied here. a minus b into a plus b equal to a square minus b square. So in this sense of mind, a square means 1 plus x to the power 2 minus b square means 1 to the power 2 divided by x into bracket root of 1 plus x and then plus 1 I have written. So simplify this here. So what happens you see here. Now let me continue here only. This is equal to square and root cancels, 1 plus x remains minus 1 divided by limit is to be written outside. Limit symbol is to be written. Limit x tends to 0. Square and limit cancels, 1 plus x minus 1 divided by x into bracket root of 1 plus x plus 1 here. Okay. Now let us simplify this. See, this is equal to what? Please concentrate. I would like to write here. Limit x tends to 0, you write as it is. X tends to 0. Plus 1 and minus 1 cancels, remains what? X remains divided by x bracket root 1 plus x and then plus 1 you can write here. Now it is the time to eliminate x and x from both numerator and denominator. You eliminate these two. Now remains what? 1 divided by root of 1 plus x plus 1 remains. For that you substitute x equal to 0 here. Now direct substitution here. So by substituting, after substituting x is equal to 0, no need to write the limit symbol. When you substitute x equal to 0, x tends to 0, that means for calculation purpose you are going to substitute x equal to 0 here. After substituting x is equal to 0, no need to write the limit symbol. So that's why what to write? 1 divided by root of 1 plus 0 plus 1 I would like to write. So 1 upon root 1 value is 1 plus 1. So final answer is 1 by 2. So this is what the rationalization method. Have you followed this? Now see students, let me proceed with the next evaluation of the limits by standard methods. That is some standard limits are there here actually. In the standard limits, first one is this one, you know, that is a, I would like to take first one. Limit x tends to a. This pattern is to be remembered properly. That is very important here. X raised to n minus a raised to n divided by x minus a. Carefully observe here. X tends to a is there. Same x is there here. X raised to n, a to the power n divided by x minus a. This is equal to n into a to the power n minus 1. Where n is a rational number. N is any rational number. It is a positive integer or it may be a negative integer or it may be a fraction. In all the cases the result holds. Limit x tends to a, x raised to n minus a raised to n divided by x minus a equal to n a to the power n minus 1. See, in order to prove this, you need to remember the formula. See, we need to use the formula. What's that here? You see here, using, just remember this one as a formula here. If you divide x raised to n minus a raised to n by x minus a by long division method, you will get an expression in this manner actually. X raised to n minus a raised to n, its expansion. See, it's you remember it as a formula. X minus a is the first factor and the next factor is very lengthy, please remember properly. X to the power n minus 1, first one, plus x to the power n minus 1 into a plus x to the power n minus 2 into a square plus, see, this is n minus 2 here, n minus 2 into a square plus so on. Lastly, a to the power n minus 1 you can write. See, this is what the expansion of, this is what the formula for x raised to n minus a raised to n. You remember, memorize it. Now let me take the LHS part of the proof. What we need to prove, LHS is equal to limit x tends to a is there here. Limit x tends to a, x raised to n minus a raised to n divided by x minus a is there. Okay. limit x tends to a, x raised to n minus a raised to n divided by x minus a. This is equal to limit, I would like to write as it is, x tends to a also as it is. Please concentrate. I am going to write x raised to n minus a raised to n as the first factor is x minus a, next one is x raised to n minus 1 plus x raised to n minus 1 into a, sorry, I have done a mistake, x raised to n minus 1, next x raised to n minus 2, ಇದು decrease ಆಗ್ತಾ ಹೋಗ್ತದೆ, this is n minus 3. See, the power of x goes on decreasing and the power of a goes on increasing. A raised to 0, a raised to 1, a raised to 2, so on up to a raised to n minus 1 here. n minus 1 first correct ಇದೆ, next decrease ಆಗ್ತಾ ಹೋಗ್ತದೆ. So this is n minus 2, not n minus 1, it is x raised to n minus 1 into x raised to n minus 2 into a plus x raised to n minus 3 into a square plus so on. Lastly, what we can write here, a to the power n minus 1 we can write. Okay, divided by what to write, x minus a you need to write, x minus a. Now see what happens, this x minus a and x minus a cancels, remains what, limit x tends to a, this is equal to, you will get limit x tends to a, x tends to a, first term is x raised to n minus 1, second term is x raised to n minus 2 into a is there here, next is limit, sorry, no limit here, simply the term you need to write here, plus x raised to n minus 3 into a square plus so on, lastly a to the power n minus 1. Now it is the time to evaluate. Direct substitution is possible. If you take direct substitution, it will not take 0 by 0. Here in the previous case, it will be taking. At the beginning, if you see x equal to a, if you substitute, it becomes a raised to n minus a raised to n 0 divided by a minus a 0. 0 by 0 format is taking here. But now, it is all reduced here. So this is equal to x tends to, I am evaluating by direct substitution method. X tends to a, you put a here, a to the power n minus 1 plus a to the power n minus 2 into a plus a to the power n minus 3 into a square plus dash dash lastly a to the power n minus 1. There is nothing to substitute there. See students, concentrate carefully, a to the power n minus 1 I would like to write. Can you tell me what is the simplified value of a to the power n minus 2 into a according to the indices property? Nothing means the power is 1 here. Bases are same, you can add the indices. I have given you the hint, please tell me.
A minus.
A to the power, not a minus. A to the power, what we can write? Come on.
N minus 1.
N minus 1, very good. Yaradidrama? Who told that answer? Lalita. In bit to Barador Hedrama? Barador Hedrapa? A to the power n minus 3 into a square equal to what? Again, what it is?
A to the power n.
A to the power n minus 1 plus so on. Again, lastly, a to the power n minus 1 is there. See, one link I would like to explain in order to conclude this. In one day, one step is there. But before concluding this, I would like to give an example here. 3 plus 3 plus 3 plus 3 plus 3 plus 3 I would like to write. The sum is 15. 3 is added 5 times. As a multiple, how we can write? Added 5 times. So 3 into 5 equal to 15. See, both are same. See, in this situation, a to the power n minus 1, a to the power n minus 1, a to the power n minus 1, so on, a to the power n minus 1 means it is added n times. Okay. A to the power n minus 1, which is repeated how many times? N times, added n times. So as a multiple, how can you write it? How can you write it? It is added n times. See, 3 is added 5 times. So 5 into 3 we have written. Then 5 into 3, 5 into 3. 3 is added 5 times, we have written 5 into 3 or 3 into 5, that is also correct, no problem. Okay, in this case, a to the power n minus 1 is added n times. So how can you write it? Come on.
N into a to the power n.
Yes, we shall correct it. N into a to the power n minus 1. Therefore, our conclusion is limit x tends to a, limit x tends to a, x raised to n minus a raised to n divided by x minus a equal to n into a raised to n minus 1. This is a very, very important result here, one of the standard limit here. Limit x tends to a, x raised to n minus a raised to n divided by x minus a. This pattern needs to be memorized properly. Pattern needs to be understood properly. This is equal to n a to the power n minus 1. Okay, a to the power n minus 1. One simple example I would like to give. Previously, ಅದು ಆಗಲೇ ಬಂದಿದ್ದ ತಗೊಳ್ತೀನಿ ನೋಡಿ. Limit x tends to 2 x square minus 4 divided by x minus 2 ಏನೋ ಬಂದಿತ್ತು. Okay, yes, this is. Now observe here. This can be written as, ಇದರ ಆನ್ಸರ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿದ್ರೆ ಆಗಲೇ ಎಷ್ಟೋ ಬಂದಿದೆ. X ಅದು ಫ್ಯಾಕ್ಟರೈಸೇಷನ್ ಮೆಥಡ್ ಮಾಡಿದ್ರೆ ನೋಡಿ. X square minus 2 square I can write divided by x minus 2. See, this is equal to limit x tends to 2, you write here. See, x tends to a. In place of a, 2 is there. In place of a also 2 is there. In place of x tends to a, that is 2. X raised to n minus a raised to n. See, 2 raised to 2 is there. So, in place of n, 2 is there here. N a raised to n minus 1 means 2 into 2 raised to n minus 1. That is 2 minus 1 here. So, 2 into 2 minus 1 is 1 only. 2 into 2 is 4 here. So, this is what the answer here. Or one more example. ಇಲ್ಲಿ ಎರಡು ಸೇಮ್ ಬಂದು ಅವು ನಿಮಗೆ ಗೊಂದಲನೂ ಆಗಬಹುದು. ಇನ್ನೊಂದು ರೀತಿನ ತಗೋಬಹುದು ನೋಡಿ. Please concentrate here. In this manner also you can take. Limit x tends to, okay, limit x tends to 3, x square minus 9 divided by x minus 3. At the beginning I have given this example, its answer is 6, you know. See, this is equal to x square minus 3 square divided by x minus 3. This limit as it is, limit x tends to 3 here. See, in place of a, 3 is there here, in place of n, 2 is there here. X raised to n minus a raised to n divided by x minus a. So, the answer is n is 2, a is 3, n minus 1, that is 2 minus 1. Its answer is definitely 6.